So we talked yesterday about exponential functions. Anything where the variable is in the exponent, exponential functions. Logarithms are inverses of those. Kind of like squares and square roots. Inverse functions. One undoes the other. Logarithms have a couple of uses. Okay, they're very, very useful for a couple of things. One, in statistics, if you have data that's not really great, one of the things you can do is called naturalization of your data, which you take the logarithm of all your data, and then you analyze the logarithms of your data, and then you use that to interpret what's going on with the real stuff. We're not going to do that here, but it is extremely useful. If you collect a bunch of data and it looks like crap, take the logarithms, see what that looks like. Okay? It's a very useful tool. What it's more useful for, what we will use it here for, is solving exponential equations. If we have something raised to a variable exponent, there are several ways to solve them. Logarithms is one of the better ways, and sometimes the only way you can solve them. So logarithms are extremely useful trying to solve exponential equations. That's the big thing we're going to be using for in here. But there's also a lot of other things that logs get used for. And the first part really is manipulating. Okay. So logarithmic functions, the inverse of an exponential function. Common logarithm is a logarithm base 10. And we'll talk about bases in a minute when I start putting examples up. You'll understand when I'm talking about bases. But here's the key concept. A logarithm and an exponential are inverses of each other. One can be rewritten as the other. And that's what we're going to be doing a lot of today. Down here in the bottom of the notes, in the bottom you already have this printed on yours. The loop method is going back and forth between logarithms and exponentials in order to solve the equation. If I have a logarithm and I want to solve for x, maybe I want to rewrite it as an exponential to do that. That's what we're going to do today. I can also take an exponential and rewrite it as a logarithm to solve for x, to solve for my variable. Going back and forth between the two is an important thing. That's what we're going to spend the beginning of today doing, is going back and forth between the exponential and the logarithm. I want you to notice the base of my logarithm and the base of my exponential are the same number. What swaps are the two things. And to understand what a logarithm is, a logarithm is what number do I raise this number to get x. So if b to the y is equal to x, the logarithm base b of x is y. What is my exponent here that gives me that? So when I go to the next page and I put numbers to it, you'll kind of understand a little bit what I'm talking about and what logarithms and how they work. Okay, but logarithms are very, very important. If you look on your calculator, you will see a logarithm key, LOG. Okay, you should look for LOG, logarithm. That is log base 10. You do have one other base built into your calculator. Log base E, it's ln. It's called the natural logarithm. We don't use the natural logs in this class, but that's almost exclusively what I use in calculus. And when you guys get to the pre-calc course, and I discuss the pre-calc calculus thing with you guys. Now, although those of you that were not here, I may talk about that again a little bit. But when you use it next year, you'll use a lot more base E. E is a number. It's very just like pi. It's the same idea. It's a letter that stands for a particular numeric value, just like pi does. And we use it a lot in logarithms and exponentials. It's a big, big deal. We just don't touch on it in here. Okay. So let's go to the first set of things we're going to do. What we're going to do is rewrite them in logarithm or exponential form. Okay. I'm going to take the logs in the beginning, rewrite them as exponentials, then we'll take these exponentials and rewrite them as logs. And you'll kind of see the relationship between the two. Because that's the important piece here. At the beginning is the relationship between those two equations. One can always be rewritten as the other. Okay, so my first one, I have log base 2 of x equals 3. That's exactly how you say it. Log base 2 of x equals 3. So my first question when I go to rewrite it, my first thing is, okay, what's my base? My base is 2. So my base of my exponential is going to be 2. I'm going to have 2 to some power. Okay. That power is what the logarithm is equal to. 2 cubed is equal to x. Now, I'm not asking you to solve it here. We're not solving anything at this point. We're just rewriting them. Okay, because you've got to be able to rewrite before worrying about solving. We will be solving in a little bit. Right now, we're just rewriting them. Okay. So log base 2 of x is equal to 3. What I'm saying is, what number do I raise 3 to get x? Or 2 to what power gives me x? Okay. So what is x here? It's 8, right? If I were to solve this, and we're not solving this, I'm not doing this for solving purposes, but I want to try to get you to wrap your head around what the logarithm is. So 2 cubed is actually 8, right? So if I take this x and replace it with 8, what the log base 2 of 8 is what power of 2 gives me 8? That's what that is. That's what a logarithm is. What power of 2 gives me 8? Oh, 3. If I take 2 to the third power, I get 8. That's what a logarithm is. What power of this number gives me that? Okay. So let's do the next one. Let's convert the next one over. Okay. So same thing. What's my base here? 3. So I'm going to have 3 to what power? To the x equals 81. So if I were trying to look at this as a logarithm, 3 to what power gives me 81? And we will be solving these problems later. Okay, so yeah, 3 to the 4th power. So in this case, x would be 4 because 3 to the 4th is 81. So 3 to the 4th power gives me 81. 3 to the 4th power gives me 81. Okay. So the next one, what's my base? My base is 5. What's my exponent on it? X. 5 to the x equals 25. Okay, the next one, what's my base? X. X to what power? The 2nd power equals 49. Good. If you can get this down, this is really, really the first important step. If you can get this down, a lot of stuff that follows will be doable much easier. This one you have to be able to do first. Now we're going to go the other way around. So now I'm going to have a log. So what's the base of my logarithm going to be? 3. Log base 3 of 81 is equal to x. Okay. See the relationship between the two? It's important you see where you place things. Okay. So what's the base of my logarithm on this one? 2. So I have log base 2 of what number? Of 64 is equal to x. There are ways to take logarithms of bases other than 10. We don't do that in here. You're welcome. We'll figure out other ways to solve the problems. Okay, what's my base on this log? Log base what? X of what number? 27 equals 3. And this one is log base 6 of x equals 2. Being able to go back and forth between these two will make not just today easier, but the next 2 lessons as well. It really does. You've got to be able to get this down. So, your turn, do these. Do these. Okay, so after our other side discussion, should be easy. So 6 to the x is equal to 36. X cubed equals 27. 4 to the 0 power is equal to x. Log base 2 of 16 equals x. Log base x of 1 is equal to 4. And log base 5 of x equals 3. That's what you should have for this. Okay. Okay. Now we're going to try solving them. Now, if I have log base 10, pull out your calculator, log base 10 of 6, you're going to take the log of 6. But these aren't base 10, these are base 6, 2, 3, whatever. If you see logarithm, just log, with no number, that's log base 10. Okay? We don't have that. You can't just pull your calculator out and do that. There is a formula for it. It's a very complex formula we don't teach. Instead, what we're going to do is use the loop method, which, if you looked on the front page, we talked about the loop method. Rewrite it. Rewrite this in exponential form, and then solve the equation. So if I rewrite this as an exponential, I have 6 to the x is equal to 6. Okay. Now, solving these different ones require different methods for finishing off the problem. Here's one of them. If my base is the same and the things are equal, then the exponents also have to be equal, right? If I have 6 to some power equals 6 to some power, those two powers have to be the same, right? Does that make sense? So 6 by itself is 6 to the first power. Bases are the same. The exponents have to be the same. That's a key to solving these equations. If you can rewrite them so they have the same base, this one already had the same base, then the exponents are equal. Yes?
On the test, if it tells us to rewrite it, do we have to rewrite it, or if we know it? You
have to rewrite it still. If it asks you to, please use that method. My calculus kids found that out. They used the wrong method on a few problems, and we got 0 points and a couple of days on the test I gave them today. Yes, there was much weeping and crying. Well, not completely, but there were some upset students. So, same thing on the next one. First step, rewrite it. 2 to the x equals 8. Now, do I have the same base? No. Can I take 8 and write it as 2 to some power? 8 is 2 what? 2 cubed, right? If I can rewrite them so they have the same base, you will be able to do this on today's problems if it's necessary. There are other ones you can't. We'll deal with those at another time. Okay? But these ones we'll be able to get so they have the same base or something else, depending upon the individual problem. 8 is 2 cubed. So I have 2 to the x equals 8. That means 2 to the x equals 2 cubed, which means x equals 3. Next one, first step, rewrite it. 3 to the x equals 27. Can I rewrite 27 as 3 to some power? Yeah. 3 to the x equals 20 equals 3 to what power? 3 to the third, so x equals 3. Same thing on the next one. Okay. 5 to the x equals 1 over 25. Okay, so this is a little more difficult, but it's still doable. Okay, 25 is 5 to what power? 5 squared. So 5 to the x is actually equal to 1 over 5 squared. But I don't want 1 over 5 squared. I want 5 to some power, right? So that means 5 to the x is equal to 5 to the negative 2. Move it up in the numerator, change the sign. So x equals negative 2. Yeah. Okay. So this one's 7 to the x equals 49. 7 to the x equals 7. What? 7 squared. So that means x equals 2. 11 to the x equals 1. Ooh, this one's a little tricky. Anybody hazard a guess?
0.
0, because anything to the 0 power is 1. If I see some number raised to the x and I get 1, that means x equals 0. Okay. Excuse me. Same thing on the next one. Log base 10 of 1,000 is equal to x. So that means 10 to the x is equal to 1,000. 10 to the x is equal to 10 to what power? How many zeros do we have? We got 3 zeros. Third power. X equals 3. Okay, let's take a quick pause. Pull out your calculators. Find the log key on your calculator. Take the log of 1,000. What'd you get? 3. Because the log on your calculator is log base 10. Okay. If you did that for any of the rest of them, it wouldn't work. But it will for that one because it's log base 10. Okay, and then the last one on this page, 4 to the x is equal to 64. 4 to the x is equal to 64 is 4 to what power? Third power, 4 cubed. X equals 3. Now, a word about some of these problems. All of these are nice because they're raised to the second or third power. For the most part, it was pretty easy. If you don't know, try 4 squared. What's that? 4 cubed. What's that? 4 to the fourth. Try that. Until it matches up. Then you can do that. That'll work for you. Okay. Remember I told you you need to know your perfect squares. You need to know your perfect cubes, 1 through 5 cubed. This will be very helpful with this stuff here. Okay, your turn. Do those. Same concept. Do those. Okay, let's go ahead and do these. So the first one, 2 to the x is equal to 16. 2 to the x equals 2 to the fourth, so x equals 4. Okay, shh. The next one we talked about, you can't do this one with the skills you currently possess. You will learn how to do this. 2 to the x is equal to 1/8, which is equal to 1 over 2 cubed. So 2 to the x is equal to 2 to the negative 3. X equals negative 3. 6 to the x is equal to 1, so x equals 0. Zip, zilch, nada. Big bagel, big donut, but not a beignet. 4 to the x is equal to 1 over 16. So 4 to the x is equal to 4 to what power? Negative 2 power. So let me scroll this. So that means x equals negative 2. And 5 to the x is equal to 125. 5 to the x is equal to 5 cubed. So x equals 3. Yes?
So on the test, we have to do 5x.
I want to see that if it's a non-multiple choice question. Yes. I need to see the work as well as the answer. No bald answers. That means no work to go with the answer. That's a bald answer. Okay. Kind of same idea. Only not all of these are going to work the same. Okay. So let's work these ones together. See what we get. See how we go on it. So the first one, my base is 5. 5 to the x is equal to 125. And we did this on the other side, right? So 125 is 5 cubed. Equals 5 cubed, so x equals 3. Okay. Next one. What's my base on the next one? X. So I have x to the first power is equal to 5. A little more difficult. Different. Not real hard on this one, is it? What is x? 5.
Was the first one the same as the last one?
Yeah, this one was actually the exact same as the last one, I think. Yep, it was. Okay. Some will be different, some won't. So this is on this one, x equals 5. Sorry, I should have changed color to keep them separate. Next one, what's my base? 27. So I have 27 to the 2/3 power is equal to x. Okay. I can't get the same powers on this, but I do know how to do this. We did 27 to the 2/3 power. We did this in the last chapter. A lot of stuff from the last chapter is going to pop up in this one. Rules of exponents. What does the 3 in the denominator mean? Take the cube root. So the cube root of 27 is 3. So that means 3 squared is equal to x. So x is equal to 9. We did this. This was last chapter. We did that in the last chapter. Okay. We didn't see it start out as a logarithm, but we convert the log over. Oh, we know how to do that. We did that in the last chapter. What's my base on this? 6. So I have 6 squared is equal to x. Okay, 36 is equal to x. They're not all the same. You kind of have to look at, ooh, what do I need to do to solve the problem? What's my base on the next one? X. So I have x to the 1/2 power is equal to 3. Ooh. Interesting. What does it mean to be the 1/2 power? That means I'm taking the square root, right? Square root of x is equal to 3. How do I get rid of a square root? Square both sides. So x equals 9. The next one, we have log base 3 of 27 is x. That means 3 to the x is equal to 27. We did this one on the other side. 27 is 3 cubed. So x equals 3. Woohoo! Lots of really hard problems. Okay, so not everybody's enthused as I am. Okay. So this is x to the -3 power equals 1/64. All right. I can't make x into, I can't make 1/64 x to some power. But what I can do is say, all right, can I rewrite 1/64 as a power of -3? Can I do that? So 1/64 is the same as 64 to the -1 power, right? You bring up the negative power. Is 64 something cubed? Yeah, 4 cubed. 4 cubed is 64. So that means x to the -3 is equal to 4 to the -3. 4 to the -3 power is 1/64. 4 cubed is 64. The negative puts in the denominator. If the bases are the same, the exponents have to be the same. By the same rule, if the exponents are the same, the bases have to be the same. Something to the -3 equals something to the -3. Those two things being raised to the -3 power have to be the same. So what's x? X is 4. I didn't match the bases, I matched the powers. X equals 4. Okay. Rewrite the next one. 2 to the x is equal to 1/32. So can I write 1/32 as 2 to some power? That's what I want to try to do here. So 32 is 2 to the 5th. 1 over that would be 2 to the -5. So 2 to the x is equal to 2 to the -5. x equals -5. If the bases are the same, the exponents are the same. The exponents are the same, the bases are the same. Same thing here. 2 to the x is equal to 1 over 16. I actually think we did this on the other page. Yeah, 2 to the 1 over 16, that's 2 to the -4. So x equals -4. Okay. This one's 4 cubed is equal to x. That's easy enough. 64. Uh, 3 to the x equals 81. Is 81 3 to some power? 3 to the 4th power. So that means x equals 4. 3 to the 4th equals 3 to the x. If the base is the same, the exponents are the same. The exponents are the same, the bases are the same. Okay. And then the last one, x squared equals 49. What squared equals 49? 7. X equals 7. Okay. Questions? Okay, your turn. Okay, let's go ahead and finish this up. Looks like everybody's done or very, very, very close to it. So log base x of 8 is 3. So x cubed is equal to 8. X cubed equals 2 cubed. So x equals 2. 4 to the -2. Shh, guys. Ladies. Okay, 4 to the -2 is equal to x. That's easy. 4 to the -2. 1 over 16 is equal to x. 3 to the x is equal to 1 over 27. 27 is 3 cubed, so that's 3 to the -3. So x equals -3. X squared equals 121. What squared is 121? 11. Three to the 5th is equal to x, so 243? Yeah. 243 is equal to x. 2 to the x is equal to 64. 64, 2, 4, 8, 16, 32, 64. 2 to the 6th. So x equals 6. X to the 1/2 is equal to 9. Remember, the 1/2 power means the square root of x is equal to 9. So square root of what? 81. Square both sides, you get x equals 81. 8 to the -2 is equal to x. So x equals 1 over 64. 36 to the 1/2 power is equal to x. 1/2 power is square root. Square root of 36 is 6. X equals 6. X cubed is equal to 1 over 64. I think we actually did this one. So x cubed is equal to 4 to the -3. 64 is 4 cubed. Put it up to get rid of the negative. X equals x equals 4. If the exponents are the same, the bases are the same. X to the -1 equals 1 over 11. What is x? (11 to the -1). Powers are the same. Bases are the same. And last but not least, 27 to the 1/3 power is equal to x. 1/3 power, that is the cube root of 27. Cube root of 27 is 3. X equals 3. And I do believe that's all there is to this lesson, right? Yay! Aren't you so happy about that?